In the last 24 hours, our star has fired off a rapid-fire burst of solar flares, one of them powerful enough to send a shockwave rippling across the face of the sun. And right now, a cloud of charged particles is racing toward Earth at over 1 million miles an hour. It's expected to slam into our planet's magnetic field within days, almost exactly as a blood-red lunar eclipse darkens the sky. And across the internet, a single question is spreading faster than the storm itself. Is the sun somehow connected to the earthquakes and eruptions shaking our planet right now? By the end of this video, you're going to have a real science-backed answer to that question, one that's far more interesting than the myth. So if you want the truth about what's actually happening between the sun and the earth this week, stay with me and subscribe, because this is a story that's still unfolding. Let's start with what is genuinely happening, because the events themselves are remarkable and you don't have to exaggerate them to feel the weight of it. On August 20th, 2026, a sunspot region cataloged as region 4513 unleashed a flare rated M8.1. To understand why that number matters, you have to understand how solar flares are measured. Scientists sort them into classes by the amount of X-ray energy they release, using letters C, then M, then X, each step roughly 10 times stronger than the one before. C-class flares are minor. X-class flares are the giants that can knock out radio communications across whole continents. M-class flares sit in between, and an M8.1 is right at the top of that middle tier, just a hair below the X-class threshold. It was the strongest flare our sun had produced in roughly 2 months, and it did not come alone. It arrived as part of a whole sequence of M-class flares rippling out of the same active region over a matter of days. Now here's the first detail that hooks people, and it's completely real. When a flare that's strong erupts, it doesn't just release a flash of light. The largest ones can blast a colossal cloud of magnetized plasma out into space, something scientists call a coronal mass ejection, or CME. Think of a flare as the muzzle flash and the CME as the cannonball. The flash of light from a flare reaches Earth in about 8 minutes, traveling at the speed of light, and it instantly ionizes the upper atmosphere on the daytime side of the planet, sometimes causing brief radio blackouts. But the cannonball, the CME, is slower and heavier. It takes anywhere from 1 to 3 days to cross the 93 million miles between the sun and Earth. And that is exactly what's inbound right now. A CME launched from this active region is on its way, with forecast models pointing to an arrival window around August 28th and 29th, though NASA's space weather modeling hints it could show up a little earlier, possibly the morning of the 28th. When that cloud finally reaches us, it collides with Earth's magnetic field, our invisible protective shield, and it makes that shield ring like a bell. The technical name for that ringing is a geomagnetic storm. And this is where the story gets genuinely beautiful rather than frightening, because the most common and most spectacular consequence of a geomagnetic storm is the aurora, the northern and southern lights. When those charged particles funnel down along Earth's magnetic field lines and slam into oxygen and nitrogen high in our atmosphere, they make the sky glow green, red, and violet. A strong enough storm can push those auroras far south of where they normally appear, sometimes into places that almost never see them. But before we go any further, I want you to hold on to a specific question, because we're going to come back to it and answer it honestly. There's another sunspot region on the sun, and there's a feature called a coronal hole nearby, an area where the sun's magnetic field opens up and lets the solar wind stream out faster. Some observers have suggested that this coronal hole could deflect an incoming eruption, steering a future blast more directly at Earth. Is that real, or is it wishful pattern hunting? Keep that in mind, because the answer tells you a lot about how careful you have to be with space weather claims. For now, let's talk about the radiation piece, because this part is also verifiable and genuinely important for anyone paying attention to the sun. Around August 20th and 21st, a long-duration flare erupted from near the edge, or limb, of the sun, and it sent a wave of high-energy protons washing over our planet. Scientists measure this as proton flux, specifically the count of protons carrying more than 10 million electron volts of energy. That unit, the electron volt, is just a way of describing how much energy a single particle carries. And for a proton, it comes down mostly to speed. A proton always has the same mass, so the closer it's pushed to the speed of light, the more energy it packs. During this event, that high-energy proton count climbed to several times its normal background level. Ordinary readings sit somewhere around 1/5 of 1 unit on the scale forecasters use, and this event pushed it well above 1, roughly 5 to 7 times normal, brushing right up against the threshold for what's officially classified as an S1 minor radiation storm. Why does that matter to you, standing safely on the ground? Honestly, for the average person, it doesn't pose a direct danger, and that's an important thing to say clearly. Earth's atmosphere and magnetic field absorb the vast majority of these particles. Where it does matter is for astronauts, for satellites, and for aircraft flying polar routes at high altitude. where the shielding is thinner. Solar radiation storms can degrade electronics in orbit and force airlines to reroute flights. So this is a real operational concern for the people who run our technology in space, even if it's invisible to the rest of us. And that distinction between something that's genuinely significant and something that's genuinely dangerous to you personally is exactly the kind of nuance that gets lost when this stuff goes viral. So here's where the mystery at the heart of this video really takes shape. All of this solar activity is unfolding at the same moment as two other events that a lot of people find irresistibly meaningful. The first is a partial lunar eclipse on August 27th, a deep one, with the moon sliding far into Earth's shadow and taking on that famous blood-red color. The second is an astronomical alignment called the superior conjunction of Mercury, when Mercury passes on the far side of the Sun as seen from Earth, lining up Sun, Mercury, and our own planet. Put those together, a burst of flares, an incoming solar storm, a blood moon, and a planetary alignment all in the same week, and you can understand why people start connecting dots. The human brain is a pattern-finding machine. When dramatic things cluster in time, it feels like they must be related. And this is the moment I want to be completely honest with you, because you clicked on this expecting the truth. Here's the second question I'd genuinely love you to answer in the comments before I give you the science. When you saw all these events line up this week, did your gut tell you they were connected? Be honest. There's no wrong answer, and I ask because that instinct is the very thing we're about to examine. Drop your answer below. Now let's take the claims one at a time, because they deserve a real response, not a dismissal. First, the idea that the Mercury alignment is somehow driving the sun's flares. It's a compelling thought. Mercury is the closest planet to the sun, and it does have a weak magnetic field of its own. But when scientists have looked carefully and repeatedly for any link between planetary positions and solar activity, they have not found a physical mechanism or a reliable statistical signal that holds up. The sun is staggeringly massive, about 1/3 of a million times the mass of Earth, and Mercury is a tiny, distant world by comparison. The gravitational and magnetic influence Mercury could exert on the sun's churning, superheated plasma is vanishingly small, far too weak to trigger a flare. Solar flares are driven by the sun's own internal magnetic dynamo, by twisted magnetic field lines in active regions that build up tension and then snap, releasing energy in an instant. The sun is currently near the active phase of its roughly 11-year cycle, and that, not the arrangement of the planets, is why it's been so lively. When flares seem to coincide with the planetary alignment, it's the same reason two friends sometimes text you at once. Coincidence, amplified by the fact that you notice the hits and forget the misses. Second, the notion that a full moon or lunar eclipse acts like a giant mirror reflecting ultraviolet, X-ray, and gamma radiation down to charge up the Earth. This one is worth unpacking because it sounds scientific but isn't accurate. The moon does reflect sunlight, that's why it glows, but it's a remarkably poor mirror, bouncing back only around 12% of the light that hits it. Its surface is dark, roughly the shade of worn asphalt. And crucially, a lunar eclipse is when the moon moves into Earth's shadow, meaning it's receiving less sunlight, not more, which is precisely why it dims and turns red. The red color comes from sunlight bending through Earth's atmosphere, the same effect that paints our sunsets, wrapping around the planet and faintly illuminating the moon. So an eclipse is not a surge of reflected radiation flooding the Earth. It's the opposite. It's a shadow. The amount of energy the moon delivers to Earth at any phase is a minuscule fraction of what we get directly from the sun every second of every day. And third, the biggest claim of all, that solar storms, eclipses, and alignments are triggering the earthquakes and volcanic eruptions we've been seeing. This is the one that spreads the fastest and worries people the most, so let's give it the clearest answer possible. The overwhelming scientific consensus, from agencies like the United States Geological Survey and from decades of research, is that solar activity does not cause earthquakes or volcanic eruptions. The energy that powers earthquakes comes from deep inside the Earth, from the slow, relentless grinding of tectonic plates against one another, stresses that build over years, decades, and centuries until rock finally fractures. A geomagnetic storm induces gentle electric currents in the ground and in long power lines, which is a real effect that engineers plan for, but those currents are astronomically feeble compared to the titanic forces locked in a fault zone. They cannot nudge a fault into rupture. There's one small, honest caveat worth mentioning, because good science includes the uncertainties. A handful of studies have found a very slight statistical hint that the moon's gravitational tides, the same force that raises and lowers the oceans, might marginally influence the timing of some already primed, shallow earthquakes and the behavior of certain volcanoes. But even where that faint signal shows up, it's tidal gravity, not reflected light, not solar flares, and not planetary alignment, and it's a subtle modulation of when a stressed fault might slip, never a cause that creates an earthquake out of nothing. It cannot be used to predict a quake, and most seismologists treat the effect as small and still debated. So if you ever hear someone claim the sun or an alignment is causing the ground to shake, that goes well beyond what the evidence supports. Which brings us back to that coronal hole and the question I asked you to hold on to. Can we really predict that it will deflect a future eruption straight at Earth? The honest answer is that coronal holes are real and their fast solar wind streams are real, and forecasters absolutely track them. But the idea of using one to reliably aim a future, not yet launched eruption at our planet is far more art than science. Space weather prediction has improved enormously, yet forecasting the precise trajectory of a CME that hasn't even erupted yet is beyond our current ability. When someone speaks with certainty about that, they're stepping past the edge of what the data can actually tell us. And knowing where that edge is, that's the whole game. So if the sun isn't causing them, what about the very real geological events that have been in the headlines? Because they are real, and they're dramatic, and they deserve their own moment. Our planet is a restless place entirely on its own. Around this same window, there was significant volcanic activity in the Pacific, with ash from eruptions climbing high into the atmosphere. Mount Etna in Sicily put on repeated fiery displays through mid-August, opening new vents and lighting up the Sicilian sky. In Ecuador, the aptly nicknamed volcano El Reventador, the one who bursts, produced a strombolian eruption on August 21st, throwing out ash, gas, and glowing rock. Guatemala's Volcán de Fuego sent a huge ash column skyward on August 22nd. And in Hawaii, Kīlauea has been in one of its episodic eruptive phases, adding another chapter to one of the most active volcanoes on the planet. Here's the crucial context that the sensational version leaves out. On any given day, somewhere between 40 and 50 volcanoes around the world are actively erupting or restless. That's not unusual. That's Tuesday for planet Earth. The Pacific Ring of Fire, the horseshoe-shaped belt of fault lines and volcanoes rimming the Pacific Ocean, is perpetually active because that's where the great tectonic plates collide and dive beneath one another. When you see several eruptions reported in the same week, it can feel like the world is suddenly convulsing, but zoom out and it's the steady background rhythm of a living, geologically active planet. The eruptions are driven by heat and pressure deep in the mantle and crust, on timescales completely disconnected from what our star did last Tuesday. And this is where I think the honest story is actually more empowering than the myth. Because the myth leaves you feeling like a helpless leaf in a cosmic storm, buffeted by forces from the sun and the moon and the planets that you can neither understand nor prepare for. The truth hands you something better. It tells you that these are separate systems, each with its own real, knowable causes. The sun runs on its 11-year magnetic cycle, and we can watch it, forecast its storms with growing skill, and protect our satellites and power grids accordingly. The Earth runs on its own internal engine of plate tectonics, and while we still can't predict the exact day of an earthquake, we can map the fault zones, build stronger buildings, and give people precious seconds of warning through early warning systems. Understanding that these forces are distinct is exactly what lets us actually do something about each one. There's a fascinating footnote to this week worth sharing too, because it shows how much genuine wonder there is in real astronomy. No myth required. Out in the distant reaches of the solar system, astronomers have been tracking one of the largest comets ever discovered, an object designated C2014 UN271, sometimes called Comet Bernardinelli-Bernstein, after the scientists who found it. Its icy nucleus is estimated to be well over 100 kilometers across, making it a true monster, dwarfing typical comets. It's slowly falling inward from the outer solar system, and its closest approach to the sun won't come until around 2031, and even then it will only reach roughly the distance of Saturn's orbit, never coming anywhere near Earth. There's no danger, but the sheer scale of it, a mountain of primordial ice larger than some small countries, drifting in from the edge of our cosmic neighborhood, is the kind of thing that reminds you the real universe doesn't need embellishment to be breathtaking. Let me pull all of this together because I promised you a payoff and I want to deliver it clearly. This week, several genuinely dramatic things are happening at once. The sun has been unusually active, firing off a series of M-class flares topped by that M8.1, and a coronal mass ejection is on its way, likely to spark a geomagnetic storm and possibly beautiful auroras around the 28th of August. High-energy protons have already brushed the edge of a minor radiation storm, a real concern for satellites and astronauts. A deep partial lunar eclipse will turn the moon red on August 27th, a stunning sight and a wonderful reason to look up. Mercury is swinging behind the sun in superior conjunction. And here on Earth, volcanoes are erupting and faults are slipping, as they always are because we live on a dynamic, restless world. What ties them together is not a hidden cosmic force. What ties them together is timing, and the human urge to find meaning in coincidence. And recognizing that isn't cold or dismissive, it's the opposite. It frees you to appreciate each of these events for the genuine marvel it is. The aurora is real. The blood moon is real. The giant comet is real. The sun's 11-year heartbeat is real. The living geology beneath your feet is real. None of them need to be secretly connected to be extraordinary. So here's my final thought for you. The next time you see a cluster of dramatic events line up and feel that pull toward a grand connection, sit with that instinct, enjoy the awe of it, and then ask the better question, what does the evidence actually show? That habit, curiosity paired with honesty, is the single most powerful tool you have for understanding the world, and nobody can take it from you. If this helped you separate the real science from the noise, do me a favor and hit that like button, because it genuinely helps more people find the honest version of these stories. Subscribe so you never miss what the sun, the sky, and the earth are doing next, and tell me in the comments which part surprised you most. This has been W for weather. Take care of yourselves, keep looking up, and I'll see you in the next one.